Okay, so in the last couple of videos, we've been working with the law of sines, and that was something that enabled us to solve what we called an oblique triangle, a triangle that didn't have a right angle in it. You know, if we have a right angle, we can just use the Pythagorean theorem and the SOHCAHTOA idea to find all the missing pieces. Okay, so the law of sines was the one where you set up a proportion. Okay, so you were able to plug in for 3 out of 4 parts of some proportion, and you're able to then use the law of sines to find the missing pieces. All right, so it's good when you're able to do that, when you're able to get 3 of the 4 parts you need. All right, but here's an example where the law of sines at least can't be used at the start. Because you see the given information I have? If I were to go up to any of the proportions in the law of sines, I wouldn't be able to have just one unknown. There'd be more than one unknown, and so I couldn't proceed. So that's why this new idea, this law of cosines, is needed, okay? All right, so the law of cosines, and I wanted to kind of show you that, but anyway, I'll just explain it. So the law of cosines says that if you take one of the sides, a squared, that would be equal to the square of the other 2 sides added up minus 2 times BC times cosine A. And that's what it would look like when you had the side A isolated. Then this needs to be cosine A over here. And you see where the remaining 2 sides would go? Then these are just 2 other forms. Okay, but it's basically that same concept. See how whatever side is over on the side by itself, that's what's over here for the angle that you got to do the cosine of. And it's called the law of cosines because you use cosine in it. Okay. All right, and it's kind of interesting to note, if this had been cosine 90, say angle C was 90, and we had to do the cosine of 90, well, the cosine of 90 is 0. So that would knock out that last term, and you'd wind up having that c squared equals a squared plus b squared, which is just the Pythagorean theorem. Okay, so the Pythagorean theorem is almost like a special case that happens when you have a 90-degree angle. So you could use the law of cosines there. It's just you wouldn't. If you had a 90-degree angle, you'd be able to use Pythagorean theorem outright. You'd be able to use the SOHCAHTOA relationships and be done with it, okay? All right, so I'm not deriving the law of cosines for you. If you're interested in kind of seeing where they came from, you can read section 7.2. I just want to make sure that you can use them, okay? So let's go ahead and do 2 examples. All right, here's the one that I used earlier where it was clear that the law of sines would not help us. Okay, but what we're going to do on this one then is use the law of cosines, and we'd be able to use it to find that side right there, opposite the angle we were given. Okay, so that side squared, a squared, would equal b squared plus c squared minus 2bc, and then cosine of angle A. And remember, that's times in between each of those. Now you just plug in your information you know, right? So you know B is 7, C is 8, and you know A is 120 degrees. All right, make sure you're in degree mode. That's one of the big issues with trig. Okay. All right, so now all we got to do is work that out. Now be careful if you work it out in pieces. I think it's kind of dangerous. I almost recommend you do it all in one. All right, that would be 49. That would be 64. And then when you work this out, this part right here turns out to be negative 56, but there's a minus right there. Okay, so you got to be sure to bring down that minus. So that really turns into adding 56. So it might be better if you just type that whole thing right there into your calculator. Just make sure you're in degree mode when you do that. All right, so go ahead and do that. Do the 7 squared plus 8 squared minus 2 times 7 times 8 times the cosine of 120, and I get 169 when I do that. So a squared equals 169. So I need to take the square root. There's two square roots, but only the positive one makes sense in this context, since it's the length of the side of a triangle. So that turns out to be 13. So A is going to be 13, side A. All right, so I just found that. Now, once I found that, what I'm going to do is go to the law of sines to find one of the other angles. All right, now sometimes I have to be real careful about this. In this case, I already have the obtuse angle given to me, so that kind of saves me a little bit. I know both B and C are acute. So I have to be careful sometimes, because when I do this, I'm going to wind up having to use the inverse sine. And when you do the inverse sine of something, we found out with the law of sines that you sometimes have to consider the angle in not just the first quadrant, but the one in the second quadrant as well. Well, with this one, it won't be so bad because I already have the obtuse angle and there cannot be more than one of them. So I don't have to worry about whether I need to use the angle in the second quadrant or not, okay? So let me just get a little more room and we'll finish this problem doing the law of sines. So see how we jump to the law of sines once we get enough? See, I can see right here, for instance, that I could use that and build a proportion. And since I want to know what the angle is, I'm going to use the variation of the formula that has the angle on top. So sine of B over the length of side B has to equal sine of A, and A was 120, over the length of side A, and that we found to be 13. All right, so I'm going to use that to solve for angle B. Okay, so that means I just need to really multiply by 7 to get the sine B by itself. And let me keep the angle on that. And so then you can type that in. 7 times the sine of 120. I like to do that and hit enter, but keep all the decimals of accuracy. And then divide by 13. And right here, don't round off yet. This is not what you're looking for. This is the sine of angle B. And so I'm going to keep about 4 decimal places of accuracy at least. I actually keep the whole thing on my calculator. Okay. All right. So now to find B, I would have to do the inverse sine of that. I'm going to do sine inverse of that 0.4663. All right. So let me do that. Inverse sine. So second function in the sine button. Put in the 0.4663. We're already in degree mode from before. And what I get back is about 27.794, and it keeps going. And on that problem, it said to round, they wanted us to round the angles to the nearest degree. So 27.79, 27.8. If I rounded to the nearest degree, that would be about 28 degrees. Okay. All right, so I'm going to go back and add that to our spot where we were putting in what we found. So this, let me make it approximately. I like to just tell myself which ones I rounded on. So this was about 28 degrees. All right, and then I could use the law of sines to find angle C, but we also know that all 3 angles in a triangle have to be 180. So we could just get C by taking 180 and taking away the 120 and the 28, okay? So 180 minus the 120 minus the 28, and we wind up seeing that C would have to be about 32 degrees. All right. All right, so that's kind of how you do it. It can sometimes be more complicated if they don't use an obtuse angle in the beginning. Then when you go to use the law of sines, you should use the law of sines to find the angle opposite the shortest side. so that you know that it has to be an angle in the first quadrant. Okay, so I'll do another example of that. All right, now I wanted to look at this case. So see, on this one, we're not given an angle at all. You see that? We're given a triangle, and we're given all the sides. We know that side A is 8, side B is 10, and side C is 5. But we don't know the measure of any of the angles. Now, it's important to kind of think about things, though. Based on the lengths of the sides, I know B is the biggest one, going to be the biggest angle, A is going to be the next biggest, and C is going to be the smallest one. All right, in a triangle like this, where you're given all the sides, that's considered a side triangle. So there's no way law of sines is going to work. So we're going to jump in, and we're going to use the law of cosines. Okay. All right, now, what you want to do on this is you want to get the biggest angle figured out first using the law of cosines, okay? Because it'll determine for you whether it's in the first or the second quadrant. You'll already know the angle. You don't have to do anything tricky. I'm not stating that correct or well, but if you'll try to find the biggest angle first, then the obtuse angle, if there is one, will be kind of out of the way. You don't have to worry about that when you go and use the law of sines. So before you set up your which law of cosine form you're going to use, look at how the longest side is 10 and its opposite angle B. So that means when I set this up, I want to use the one involving the B. Now the way we had it written, we had that B squared, the side B squared, would equal the A squared plus C squared minus 2AC cosine the same angle that was isolated. So that would be cosine of angle B. All right, but when I plug in everything that I know, B is 10, A is 8, C is 5. The unknown isn't one of the sides. Okay, so A is 8, C is 5, and what I'm looking for is angle B. So we're going to do a little algebra here to first get the cosine of B isolated on a side by itself. And there's no reason to remember that form or to, even write that down, because you can just let your algebra do that for you. And then we'll have to use the cosine inverse, the inverse cosine button. Okay. So we have here that 100 equals 64 plus 25 minus 80 cosine B. Okay, so it would work well or help if I would put those two together. So that's 89. Remember, you can't do 89 minus 80 though, because those aren't like terms. This one's attached to that cosine B. But what I can do is I can take away the 89 from both sides. Okay, so that's going to leave me with 11 over here. Do that back in black. Negative 80 cosine B. Okay, and I want the cosine B by itself. In fact, you may have been preferring things. If I put the unknown on the left-hand side, sometimes people just really prefer that. Let me get that out of the way. So I could just switch the two sides. So you can think about getting this by itself. You could do it by dividing. Divide by negative 80. All right, and then we'd have the cosine B equaling 11 divided by negative 80. Now I'm going to do that. So I know it's a negative number. I don't bother typing that in. Okay, but I wind up getting, it turns out exactly this. I liked 4 digits, negative 0.1375 when I did that. Okay. All right, so now at this point, I'm going to wind up undoing. Let me bring this back up to here. I'm going to wind up taking the inverse cosine of both sides. So I'm going to do cosine inverse of the negative 0.1375, and it'll give me the value of angle B. Okay, so find your inverse cosine, type in that, don't forget to type in the negative on that, 0.1375. And what I get back is that B turns out to be about 97.90 and so on. Okay, and on this problem, they want us to round angle measures to the nearest degree. So mine was like 97.9, so I'm going to say it's about 98 degrees. All right, now here's the deal. Let's look back at what we just found and what else we have left to find. Okay, that's angle B. So I know that's 98 degrees. See how now I have 3 out of the 4 parts I would need to use the law of sines. And since I took and got the biggest angle out of the way, I know these other 2 angles are going to be acute. So it'll be a really straightforward use of the law of sines. So that's what I'm going to do now. Okay. All right, so let's go ahead and set that up. So I'm going to maybe set up a proportion that involves the A's and the B's, and it's an angle I'm looking for, so I'm going to set it up with the angle on top. So I'm going to be using the sine A over little a equals sine B over little b. And we just found out that B was about 98 degrees, and we knew side B was 10, and we knew side A was 8. What we're looking for is sine A. All right, and if I'm setting up my law of sines, I'd like to make my unknown be in that top left corner. It just makes it much clearer, I think, to people when we get ready to do the algebra component. Okay, so I want to get the sine A by itself, so I'm going to multiply by 8. Okay, that leaves me with the sine A equaling this 8 sine 98 divided by 10. Now, even though I could algebraically simplify that, they don't want an exact answer, so I'm just going to type in 8 sine 98, get that, divide by 10, and what I find is that sine A is about, I like to keep 4 decimal places, 7922 here, because this is not the answer. This is the sine of A, not A itself. Okay, so now we're just going to take and do the inverse sine of both sides. So A is going to equal sine inverse of 0.7922. See, what I did is I did this. Okay, and this is sometimes more complicated than it looks, because when you do that on your calculator, you're not always getting the measure of angle A itself. You sometimes have to check, remember, whether you need the angle in the first quadrant or the angle in the second quadrant that would have that same sign. We just don't have to do that here because we already got the biggest angle out of the way. Okay, so when I do the inverse sine of that, I get that A is about, and I'm getting 52.39, so we'll just round it down to 52 degrees for angle A. Okay, so let me go back, see where we're at. So I'm going to put the 52 in, and then you see all we have left is one more angle, so let's not make it complicated. Let's just take 180 and take away the 98, and then take away the 52, or add those 2 first and then take away that from 180. Okay, so 180, take away the 98, knocks me down to 82, and so I'm going to have 30 degrees for angle C. Okay, all right, so those are the 2 main times when you need to use the law of cosines. That was kind of a straightforward side example, and then a pretty straightforward side angle side example. All right, I want to do another few I'm going to do a lot more of these actually in another video where I kind of mix up the law of sines, law of cosine problems, even with some that have right angles in them. So you'll get some more practice with that. Also going to do a separate video that deals with just applications and another video that deals with finding areas. Okay, so this one's getting kind of long, so let me go ahead and stop this and get it posted.